Welcome back to the classroom. My name is Mr. Wong, and today we'll be covering the Module 7 Inquiry Question 2, which is all about the wave nature of light. Now, one of the components is polarization. So this is from the additional physics sample paper, question 12 for Module 7. A student was given a smartphone with a light sensor and an angle sensor in it, and a computer screen which emitted polarized light. So we're going to call this I0. A polarizer was fixed over the top of the light sensor on the smartphone. So we have another source of light that comes through at the end. Okay. What we know is if we have polarized light, so light that is going in one particular orientation, if we have another polarizer after that, we could potentially prevent any light coming through. The student wants to use this equipment to investigate Malus's law of polarized light. Describe the procedure. Is it suitable for, or describe a procedure that is suitable for carrying out this investigation. Okay, so what we can do is firstly write out or draw out a diagram setup, and then we'll go from there. So stay with me in this next minute or so as I draw out the setup. Alright, so this is a really crude drawing of the basic experimental setup. What we have is polarized light source, and we also have a polarizer that can potentially block off any light intensity from coming through. I'm going to call this light source I0, and we're going to call the light that comes through I. As this light goes through, we can sense the overall intensity of that light source, and we can also work out the angle the polarizer makes in reference to the light source itself. Okay, so let's deal with what we have here. We need to consider, if we're trying to talk about a suitable experiment, we need to talk about validity and reliability. So let's get started. Our first step is to set up the experiment as shown in the diagram. The next thing we'll want to do is to make sure we're recording the correct magnitude of light, and we're also using the same light source. We're going to say that the light source has the same intensity, and we're going to say we'll do a background reading of a darkened room. Okay, this is how we're going to do our readings. Okay, so record, what's that? Number 2, record a background in darkened room from sensor, and use a constant intensity light source. Okay. Number 3, we want to also make sure the distance between the light sources and the polarizers stay the same throughout the experiment. Again, this is about validity. And we also want to make sure that we start off at probably the maximum sensor, or the maximum light intensity. Okay, so record the distance between the light source and the polarizer, and also the polarizer and the sensor itself. Once you've done that, rotate the light source until you get the maximum intensity. Okay. So we'll rotate the polarizer until we get a max light intensity. That's going to be our 0 degrees, or that's the angle in which we'll find maximum intensity, and that's also the angle we have with the polarizer and the polarized light source coming out. Okay. Next, we're going to rotate it again and record particular angles of that rotation. So rotate the polarizer at 10 degrees intervals. So we can use 10, 20, 30, 40, all the way to 90. So that gives us a nice little display of all the different intensities of light. And we want to ensure this is a reliable experiment, so we want to repeat this recording at least 3 times. Okay, once we're done, we want to plot this on a graph and actually investigate whether or not we have followed Malus's law. Remember, Malus's law, the actual equation is I equals to I0 cos squared theta, which means that if the angle started at 0 and 90 and 180, it will go down like sort of this cup shape, down like that. So we want to investigate that. Okay, calculate intervals, repeat this recording 3 times. Plot data on graph as I, so that's the intensity of light we witness, versus cos squared theta, to investigate if Malus's law has been modeled. And that's how you do the question here. Just leave it there for now. We've shown a little diagram of how we'd set up the experiment. We went through very clearly in sequence what we need to do in order to get the measurements. We've looked into ensuring we only have one independent variable. We had our controls, that's clearly labeled here, and we also ensured for reliability. Okay, so that's how you write a scientific method of an experiment you wouldn't be perhaps familiar or usually exposed to. The next one we have is an experiment that was conducted to demonstrate Malus's law for plane polarization. So essentially just going in a straight line, if you would say. The results are shown below. Based on the graph shown, how effective was the experiment meeting the aim? Okay, so we said before that Malus's law is I equals I0 cos squared theta, which means the shape at angle 0 is maximum, 90 degrees is minimum, and then at 180 degrees it'll be maximum again. If you actually look at the graph, it does give you that sort of drop-off shape that we're looking for. So it does kind of have that drop-off shape, but maximum is not at 0. So this should be the maximum component. This is the actual maximum. But whatever we were recording, we weren't recording it at the correct angle. The shape is fine. You can see there's that little sort of plateau dip that we have here, but where the actual maximum is incorrect. Okay. Another thing you can talk about is look at the angles that we have here. We go from 0 to 90 degrees. That's a big sample size there. If we were only doing 30 to 50, you can see it's not a very clear indicator we're getting that cos sine curve there. So that's what we're looking into. Okay, so let's write a response to this. How effective is it in meeting the aim? Okay, so the first thing, let's just talk about whether or not it meets the aim. So the graph, our graph doesn't meet the aim of our investigation. Okay, it is relatively effective in the sense that it shows some parts. So let's look at where it is effective and where it's not effective, okay? So it is effective because the first one, we said the diverse range of angles used, so the diverse okay. Another thing that it is effective in, so we said that it's effective in showing a diverse range, and we can see that cosine shape there. Okay, let's look at what it's not effective. And that is where the maximum point is. You can see the maximum point should be 0 if it's a cosine graph, but it's not the case in this experiment here. Okay, so okay, we can do a final statement. So max or maximum light intensity occurs at 0 and not 30 degrees, so doesn't follow a conventional sine graph. Okay, so that's basically it. You can even write down what the Malus' law is. You can see there, sine squared theta. So because the light intensity is in the wrong position, this can't be an effective portrayal of Malus' law. You could also use the argument that it does demonstrate Malus' law. So on the contrary, we can also say that it does fit into Malus' law, so long as we acknowledge the fact that the angles are measured at the wrong position. So we could say it demonstrates that angles have been measured incorrectly, but the shape does demonstrate Malus' law, or the cos square theta. So I'm going to change it. It does meet the investigation of the aim, but one important clue that we need to look at is the fact that the angles aren't in the correct position. Alright, so hopefully this helps explain how we can actually understand whether or not the experiment has answered the aim. This experiment has, but the representation of the data is not in the correct positioning. Alright, thank you for listening and watching this video up to now. I'll see you next time.